Accurate measurement of chloride is critical to many clinical, industrial, and environmental laboratory procedures. Labconco's Digital Chloridometer is a dedicated coulometric titrator capable of providing accurate readings of chloride concentrations in minutes. Initially developed to analyze the chloride concentration in sweat to diagnose cystic fibrosis, the unit is now also routinely used to measure the chloride and sodium chloride content in a wide range of laboratory applications, including food processing, quality control, and research and development. How does Labconco's Digital Chloridometer work? It involves a chemical process and electricity. A fixed electrical current passes between two silver electrodes immersed in an acid solution. This releases positively charged silver ions, which combine with the negatively charged chloride ions in the solution to form an insoluble precipitate, silver chloride. The reaction slowly consumes the silver wire anode, also called the generator electrode. When all the chloride ions in the vial have combined with silver ions, an excess of silver ions builds up. This causes an electrical current to pass between the opposite electrodes. Sensing the current, the chloridometer automatically stops the titration process. The unit's digital readout represents the total titration time, which is directly proportional to the number of chloride ions detected in the sample. The display is in milliequivalents of chloride per liter. A milliequivalent is a measure of ionic concentration. Labconco's Digital Chloridometer comes complete with the following accessories: chloride standard, acid reagent, gelatin reagent, 200 titration vials, a stainless steel rack, a rinse bottle, silver polish, an instrument cover, and an instruction manual. Before operating the Digital Chloridometer, read the manual carefully. It contains full descriptions of everything you'll see demonstrated in this video. Let's look at the chloridometer's components. The electrode assembly, which includes 4 electrodes and the stirrer to mix the sample. A spool of silver wire that serves as an anode in the electrode assembly. Since it's consumed during the reaction, it needs regular replacement. The movable platform that raises and lowers the sample vial for testing. A thumb wheel counter for blank adjustment, used when performing individual titrations. It's not used in serial titration. A 3-position range switch. Select high for sample volumes of 100 microliters, low for smaller 10 microliter samples. The digital chloridometer can also accommodate other sample volumes. Consult the manual for details. A 3-position titration switch to the right of the range switch. The auto setting provides automatic operation. When in standby, you must depress the switch to the start position to begin a new titration. A digital readout displays the final results in milliequivalents. On the back of the unit is a compensate switch, which can correct for pipetter and certain other errors. But adjustment is complicated and unnecessary for most applications, so always refer to the manual before making any adjustments. These are the components of Labconco's Digital Chloridometer. To maintain accurate readings, you should clean the electrodes before using the unit each day. If you're running a large volume of samples, clean them more often. With the unit turned off, check the electrode assembly. Thoroughly clean all of the electrodes with silver polish. Wipe off the excess with a tissue, then rinse with distilled water and wipe clean. The generator or anode electrode should be as long as the others and thicker than an ordinary pin. If it isn't, draw fresh wire off the spool and snip off any extra length. Retighten the binding post to make a good contact. Before running an actual sample, run a series of titrations. This will establish blank values and determine the value of the chloride standard. We'll set the range switch to high for this demonstration because we're using 100 microliters volumes. You may use either high or low depending on the volume of the sample. Just remember to use the same setting to titrate all subsequent blanks and samples. You begin by pipetting 4 milliliters of chloridometer acid reagent into each of 5 clean vials. To assure accurate results, practice using a precise pipetting technique. Now place one of the vials in the holder and raise it until the electrodes are immersed. Make sure the acid solution doesn't come in contact with the plastic electrode sleeves. Depress the titration switch to start. After a short pause, the chloridometer begins counting the chloride value of the acid reagent. Repeat this procedure on 3 more vials. Blank values for all 4 of the vials should be within plus or minus 2 milliequivalents per liter. Average these 4 blank values and enter that figure on the thumb wheel counter. Next, add 100 microliters of chloride standard to the last prepared vial of acid reagent. Titrate this sample. You should expect a reading of 100 milliequivalents per liter plus or minus 2. Now you can titrate additional vials of fresh acid reagent and chloride standard. Checking with a known chloride concentration verifies the accuracy of your technique and of the chloridometer itself. If you receive widely varied readings, there are several causes, including poor pipetting techniques, dirty electrodes, or contaminated acid reagent. The manual's troubleshooting section can help you determine the cause. Now, let's titrate an actual sample on the digital chloridometer. First, an individual titration. Remember, we've already checked and cleaned the electrodes and established a blank value. We begin with 4 clean vials of fresh acid reagent, 4 milliliters per vial. Then accurately pipette 100 microliters of the sample. The range switch remains on high. With the titration switch in the standby position, raise the holder, then depress the titration switch to the start position. The unit automatically subtracts the blank value you entered on the thumb wheel counter. The displayed reading is the chloride concentration of the sample. That's the procedure for individual titration. But when you have multiple samples to process, serial titration saves time and conserves acid reagent, because you use the same vial and reagent more than once. For serial titration, set the titration switch to auto and the thumb wheel counter to 0. Pipette 4 milliliters of acid reagent into a clean vial. Place the vial on the holder, raise it, and within a few seconds the display automatically begins counting. When it stops, the reagent is free of chloride ions and ready to titrate the sample. You can disregard the blank reading since you'll be reusing the same vial and won't need to average blank values. Now you're ready to add the 100 microliter sample. The unit will start automatically when it senses the added chloride ions. When it stops counting this time, the reading represents the actual chloride content of the sample. You can continue adding new samples to this same vial until the solution becomes cloudy with precipitated silver chloride. When it does, replace the used vial with one containing 4 milliliters of fresh acid reagent. Just remember to titrate the acid reagent by itself first to free it of chloride ions. For more detailed information about running samples with very high or low chloride concentrations, consult your manual. If you find you're having difficulty getting accurate readouts, here are some areas to check. Check for physical contamination. Wear gloves to avoid contaminating pipettes, vials, and samples. Check your pipetting technique. The most common reason for inaccurate readings is an error in sample volume. Precision pipetting into a small vial is difficult and requires practice to achieve consistent reproducibility. Check the vials. Make sure they're clean and free of contaminants. Check the electrodes. polish them with silver polish at least daily, and more often when running numerous serial titrations. Check the silver wire anode. The generator or anode electrode must be the right length and diameter, and it must be securely connected to the binding post. Check for fluoride, bromide, or iodide in the sample. They're possible interfering ions that will combine with silver in the same way as chloride, so they can't be differentiated by the chloridometer. Check for protein. Very high protein to chloride concentrations can interfere with readings. Check solutions. Remember, the only time you use gelatin is when you're making your own acid solution. Don't add it to the Labconco acid reagent. And check the expiration dates. Old or contaminated solutions can affect results. Check the compensate switch. It should be in the standard position. If it's in the compensate position, the reading may be in error. The digital chloridometer can be a precise and useful tool in the determination of chloride content in a wide variety of sample types. It makes the coulometric titration process clean and efficient. Careful practice and an understanding of the chemistry behind this instrument will result in fast and accurate results. For more information about Labconco's digital chloridometer, consult the instruction manual or call 1-800-821-5525.